Hi, I'm Eric. I'm here to record the video in order to share some of my thoughts about the problems I did during the coding challenge of my UPE induction. For the coding challenge, I chose the topic of tree traversal, and from the several problems that I was asked to complete, I concluded two of the common ideas of how to deal with tree problems. The first one is divide and conquer. This is really, I think, is really an intuitive one because the tree is by its nature separated into several subtrees by the children of the root. So if you can divide the tree by their subtrees and then solve them recursively, and then bring all the results back to form your final result, then it's like a conceptually easy way to deal with it. And as I mentioned before, the implementation of divide and conquer could be achieved by recursion, like i.e., namely like function recursion. And the second one, the second common idea is the breadth first search. Sometimes you want to check check the tree or to do some things about the tree level by level. And so at this time, it is a better idea to use um, breadth first search to maintain like a level by level order. So to implement this breadth first search, the queue is a good tool because the queue is like first in first out. So every level, like every higher level, is guaranteed to come before the lower level. So when you're using queues and implement it correctly, you can guarantee that you traverse this tree level by level. And here I want to illustrate one of the examples I did, which is binary, to get like a level order list. So basically, this problem asks us to form a, like as you can see, it asks us to we are input at the root of a tree and output an array of the arrays, and each array in the arrays contains like the elements on that level. So to implement this part, I choose to use a queue, and sorry, this is for C++. I choose to implement a queue where I could separate each level and then add the elements to the integers to the elements to the arrays of the current level. So for example, here, this while loop, in each while loop, this is a level, and in this for loop, because I was I assumed that every time I finish one level, all the elements in the queues remains in the queues are all the elements of the next level. So I just store this level, store the current size whenever we started the recursion, and use this side to traverse to iterate all the elements on that level. And by the way, construct the queue for the next level. So this is an idea of the tree traversal, and actually I use some helper functions to implement my queues. So this is because we don't know a priori how large our tree is. So I have to, if I want to use the queue, I have to use dynamic allocation. And for sometimes, like there's a possible reallocation because the queue might be not big enough. So I think it's a good idea to wrap them up because it is like, as you can see, this is a large pile of code. Okay, so this is basically what I did for the queues, and for this is a divide and conquer example. So this problem basically asks us to reconstruct a tree given the pre-order and the in-order list of the tree nodes. So pre-order is like the order you get when you first access the root, and then the left subtree, and then the right subtree. And the in order is you first get the left subtree and the root, and then right subtree. So with these two information, theoretically, it is enough for you to reconstruct the whole tree. And in my implementation, as you can see, like for pre-order, it is guaranteed that the root is the first node, because the root, we always start with the root, and since pre-order, the root is always the first one to visit. So for pre-order, the root node is the first one. So the next thing I did was to try to find the position of the root in the in order list, because because of the nature of the in order list and the traversal, you will first finish all the left subtree of the root, and then you visit the root, and then you visit the right tree. So the root in the in order list is kind of a separation of the left subtree and the right subtree. So here you can see that this step was used for me to achieve the divide and conquer, because I can use the root in the in order list to divide the whole problem into two subproblems of the left subtree and right subtree. And yeah, and because in any cases, all the nodes in the left tree comes before the right tree. So we know that in the pre-order, even in the pre-order case, the ith element is also the start of the right subtree. So using these two information, this is the in-order list of the left subtree. This is the pre-order list of the left subtree. This is the in-order list of the right subtree, and that is the this is the pre-order list of the right subtree. So we can use these two pairs to form two subproblems that we can recursively solve. And then we just connect the two subtrees with our root and just add the value of the root according to this element. So the problem is solved. So this is the two common ideas I think could be used on tree traversal, and some examples of how to implement them to solve problems. Thank you.